Welcome back to the deep dive. We're here to cut through the noise and get straight to what matters. And today, we're tackling something that, honestly, it's a bit of a nightmare scenario for developers and security teams alike. We're talking about accidentally committing sensitive secrets, things like API keys, passwords straight into your code. It happens more than you'd think, and it's a massive security hole. So our main focus today is GitHub secret protection, how it helps with this. But the really interesting part, we're digging into how they used agentic AI, specifically GitHub Copilot, to massively speed up a key part of this, expanding their validity check coverage. Think of this deep dive as your shortcut to understanding how AI can be a serious force multiplier for those repetitive engineering tasks. And crucially, what lessons you can take away from this real-world example. Okay, so let's unpack this. Accidentally leaking secrets in code, why is this still such a persistent headache? It seems simple to avoid, but clearly isn't.
Well, it's easy to see how it happens, right? Developers are under pressure, moving fast. Maybe a credential gets left in a config file during testing, or a quick commit just scoops it up accidentally. And the harm, oh, it's immediate. Compromised accounts, potential data breaches. It becomes a race against time to revoke those credentials before someone bad finds them.
Yeah, a total scramble.
Exactly. And that's where GitHub Secret Protection comes in. It's designed specifically to prevent and then mitigate these leaks. It's got several layers. There's push protection, which basically tries to block the commit before the secret even lands the main code base.
Okay, stop it at the source.
Right. Then you have validity checks, and this is our main focus today. These help figure out if an exposed secret is actually active and needs urgent attention. Super important for triage. There's also a partner program, so providers get notified about public leaks and can revoke tokens quickly. And for other cases, there's Copilot secret scanning for more generic secrets, and organizations can even define their own custom patterns.
Those validity checks sound like the real lifesaver, though. If you've got hundreds of alerts, knowing which ones are actually live threats must be huge. Saves tons of time, I imagine.
Oh, absolutely. It's a game changer. Instead of chasing down every single alert, teams can focus on the ones that pose an immediate risk. It cuts down the noise dramatically and prevents potentially serious damage from, already revoked or test tokens.
Okay, so let's zoom in on these validity checks. How do they actually work? What's happening behind the scenes to see if a leaked key is, still usable?
Yeah, the mechanism's pretty neat. It works by testing the leaked credential against a specific but crucially unobtrusive API endpoint from the tokens provider.
Unobtrusive, meaning?
Meaning it doesn't perform any real action. Think of it like pinging a me endpoint, for instance. Lots of services have one. It just confirms, yep, this token is valid and belongs to this account without, say, deleting data or making changes. Just a quick, safe check.
Got it, like a status check.
It's exactly. So when GitHub rolled this out back in 2023, they covered the big ones pretty quickly: AWS keys, Google Cloud credentials, Slack tokens, that kind of thing. And that initial rollout was great. It validated something like 80% of new alerts. But adding support for new token types, that was proving to be, well, steady but slow.
Ah, the classic bottleneck.
Right. Engineers had their hands full with other feature development, their day-to-day work. So dedicating time to research and implement checks for less common but still important token types, it just wasn't happening fast enough. There was this growing gap.
I can totally picture that. You've got this critical but kind of repetitive task competing with shiny new features. It's a tough balancing act for any engineering team. Okay, so here's where it gets really interesting. We get to late 2024, early 2025, and suddenly everyone's talking about agentic AI, coding agents. And the GitHub team has this kind of a light bulb moment, right? Could these new AI tools actually tackle that backlog? Could they automate adding these validity checks for all those other token types?
That was exactly the idea. And just to clarify what we mean by agentic AI here, it's not just fancy autocomplete. We're talking about AI that can take a goal like add a validity check for this new token type, break it down into steps, and then actually do those steps like writing code, maybe configuring something. It acts more like a teammate.
A teammate that can do the grunt work, maybe. So how did they make this happen? Did they have a process already?
They did. They had a pretty well-defined human-driven 4-step framework for onboarding a new token type. It was repeatable, which is key. First, research. An engineer had to hunt down the right API endpoint for that safe, unobtrusive validation check. Often meant digging through docs.
Okay.
Second, code. Actually writing the validator code itself. Third, dark ship. This is important. They deploy the new validator, but in a sort of read-only mode. It runs, it checks tokens, but it doesn't write its findings to the database yet. Lets them see if it works, catch errors, especially if the API behaves slightly differently than the docs say.
Ah, like a silent test flight.
Exactly. And finally, step 4, fully ship. If everything looks good in Darkship, they remove that configuration and the validator goes live properly.
Right, a clear process.
Hmm.
So looking at those 4 steps, where did the AI fit in? What seemed like the obvious targets for automation?
Well, the obvious first choices were step 2, the actual coding, and step 4, the release configuration.
Makes sense.
The coding part is repetitive once you know what to code, and the release part is usually just a small config change. Those seemed ripe for an agent.
That clear framework feels like the secret sauce here. Makes you think, doesn't it? What processes in your own work have those kinds of repeatable steps, just waiting for some smart automation? Okay, so they identified the targets. How did Copilot actually do? Let's walk through the steps again. Step 1, the research finding the right API endpoint. How did the AI handle that?
Yeah, that was interesting. Copilot actually struggled quite a bit with the research part.
Oh, really?
Yeah. It wasn't great at reliably finding that least intrusive endpoint, the one an experienced engineer would pick. Things like creating live test tokens safely, figuring out subtle API changes that really still needed human judgment and experience.
Okay, so the detective work still needs a human. What about step 2, the coding? Once the human did the research, how was Copilot at writing the validator?
Now that's where it's shown. Copilot excelled at the coding. The engineers would do the research, document it really well in a GitHub issue that became the prompt.
A detailed prompt, I guess.
Oh yeah, very comprehensive. Background info, links to the API docs, examples, everything. We did find we sometimes needed to add extra notes because it occasionally had trouble following links within the prompt itself, but providing the context directly worked wonders. And the output, Copilot would generate a whole pull request ready for review. It turned the research into actual code automatically.
Wow. And was that code just used? Or did it go through review?
Yeah. Oh, absolutely review. Critically important. The AI-generated code was treated exactly like human code. Automated tests, human code review, engineer deployment. Feedback was even given back to the agent via comments on the PR. Treat it like a teammate, right?
Right, same standards. Okay, what about step 3, dark shipping? Did Copilot handle that observation period?
No, engineers kept managing the dark ship phase. That step is just too crucial for catching subtle errors or differences between documentation and reality, that API drift we talked about. Human oversight there felt essential for safety.
Makes sense. So finally, step 4, the full ship, taking it out of dark ship.
Copilot handled that part. Once the engineers were happy after the dark ship testing, the AI could make the small configuration change needed to fully release the validator. It was a simple final step it could manage easily.
So it really highlights that AI isn't some magic bullet, is it? It's a tool, a very specialized one. You need to know exactly where its strengths lie, like repetitive coding, and where you absolutely still need that human intuition and oversight.
Precisely. Understanding those boundaries is key.
So let's get to the payoff. The results. You called Copilot a force multiplier. What did that actually look like in terms of numbers? Was it really that dramatic?
It was pretty stunning, actually. So before using Copilot, remember, the engineers had onboarded 32 partner token types over several months. Steady, but slow.
Right.
With Copilot, get this, engineering interns, guided by the research done by full-time engineers, were able to onboard almost 90 new token types.
90.
90 in just a few weeks.
Wow. Okay, that is a force multiplier. How did that massive speed up happen?
It was about parallelization. We could basically take the research output for, say, 10 different token types, feed each one to a separate Copilot agent instance, and have them all working on the coding simultaneously.
So instead of one engineer working sequentially, you have multiple AI agents working in parallel.
Exactly. It massively sped up the coding and PR generation phase. But, and this is vital, it was still no replacement for human engineering judgment. The success wasn't just let the AI loose. It was about carefully grafting Copilot into very specific points in that existing framework.
Right, automating the bottleneck, but keeping humans in control of research and review.
Precisely. It freed up engineers to focus on the harder, more nuanced parts.
So it's not just coding faster, it's actually optimizing the whole team's workflow, letting people focus on the higher value stuff.
Yeah, that's powerful. Okay, so pulling this all together, for you listening, whether you're deep in code or managing projects, what are the big takeaways from GitHub's experience here? There seem to be a few key lessons. First one seems obvious. Automation loves repeatability.
Absolutely. If you have a process, any process, with clear, well-defined, repeatable steps, that's where these coding agents, or AI in general, can really shine and scale up your efforts. Look for those patterns.
Second lesson, treat the AI like a teammate, not just a tool, but something that needs oversight. Yeah, exactly. Its output needs the same level of review, testing, and feedback as anything a human produces. Don't just trust it blindly. Quality control is still essential.
Third, prompt quality is everything. Garbage in, garbage out, right?
Pretty much. The more detailed, clear, and example-rich your prompt is, including those extra notes, if needed, the better the AI's output will be. You need to guide it effectively.
Fourth lesson, be ready to iterate. You probably won't get the prompt or workflow perfect first time.
Definitely not. You learn as you go. Expect to tweak your prompts, adjust the workflow. It's a feedback loop. You see what works, what doesn't, and refine the process with the AI.
And the fifth one, which really enabled that speed, parallelization is a superpower.
That's the scale factor. If you can structure the work,
Yeah.
so multiple instances of the AI can tackle pieces concurrently, you break through those single-threaded human bottlenecks, it unlocks huge efficiency gains. So yeah, summing it up, Copilot was an incredibly powerful teammate for this specific kind of framework-driven, repeatable task. But it absolutely reinforces that AI doesn't replace thoughtful engineering. Collaboration, human oversight, review, those are still absolutely central.
And these aren't just coding lessons, are they? These principles are repeatability, review, good prompts, iteration, parallelization, they could apply to using AI in almost any structured workflow. So the big picture here is pretty clear. Smart, strategic application of AI, especially in these well-defined workflows, can genuinely accelerate things and boost efficiency, even in critical areas like security.
For sure. And this really points towards the future, doesn't it? You can see how agentic AI and coding agents are just going to keep accelerating software development, letting engineers tackle bigger, more complex, more creative problems.
Which brings us to our final thought, something for you to chew on. As AI keeps getting smarter and more capable, where in your world, in your daily workflows, maybe it is coding, maybe it's writing reports, analyzing data, managing projects, where could you identify one of those framework-driven, repeatable tasks? Where could applying some smart automation unlock that force multiplier effect for you, freeing you up to focus on the stuff that really requires your unique human creativity and insight? Worth thinking about. Maybe it's time to look at your own processes with fresh eyes.
This was the Gist Podcast. If you liked it, please leave a like and subscribe to this channel.